Sweet. All right. Now we put this one in here. Hmm. Hello, hello, hello. What's going on, everybody? If there's anybody there, I can't really see right now. I'm working on, I'm going to set up this pulse motor over here with a quasi kind of SG inspired circuit. But yeah, I'm going to do 1, 2, 3 with it. And that's what I'm working on right now. All right, I just need to get the jumper wires. Got a box of them right here. Now we're going to do the extension. All right, so this will clip to here. And to the power input of the next coil. Now, to kind of help make sure that these things aren't touching, yeah, we'll do this. Maybe we won't do this. Worked better the first time I did it. All right. Moving right along. Mm. All right, and then emitter, and we'll take the next collector and clip it to the next coil. And for all intents and purposes, this should work. Gyroscope's working pretty good. We'll take a look at that in just a second. Awesome, man. That's freaking cool. I was just checking to see if that would work, and it worked. That's so smooth, man. So let me explain it. These are not SG circuits, but they are being. This coil is connected to the power supply through this transistor. Okay. And then we do collector connection to the next coil. Okay, so there's only one power input on this coil, and everything is linked together through the transistors themselves, through the collectors. I think it's sweet. I mean, it was pulling 2 amps. It's a lot of amps. It's going to be a lot easier to switch around now. Just unclip that one, and then clip these two. For the next couple streams, I'm just going to be doing explaining these things. Now, the gyroscopic axial flux pulse motor right here, the counter rotating. Now, if I explain this and if I draw the diagram for this the way it's hooked up right now, everybody would probably miss and counterintuitively do it the other way than it is. All right, let me explain. I got the 20 gauge strands hooked up like AC style. There's no directional diode. Okay, so you clamp it, it goes up the brush, or the little wire that's on there, through the coil, 20 gauge coil, right? Anyway, the 32 gauge diode is directed to the plate. I've hooked up the 32 gauge. I've hooked it up to the plate. So when I turn it off, the electricity that is being generated by the 32 gauge is going to be, directed to the plate, so it can be picked up by the other brush in the 22 gauge. Let me show you what's going to happen. Everything's going to the bottom's going to stop. It's going to become like a regular motor. All right, power's off. But this top part right here, as long as the brush is touching the plate, when it stops, because the plate's a little bumpy, but as long as the brushes are touching the plate when it stops, the 32 gauge electricity will go into the plate and up to the 22, continue making this move more. But of course, since there's no source really, except the 32 gauge and the motion of the rotor, it'll stop. It has to stop. Each time it goes around, there's loss, so it's going to stop. But it'll go longer. And I'm demonstrating that right now. It is now moving pretty much at speed. We're going to try and get how fast it's slowing down. I hear it slowing down, and it's going to stop. But it's slowing down very slowly. And that was my objective, to get it to slow down slower. Yes, yes, flux capacitor. I'm glad I got to look over and see that right here. I mean, we're not going to call it that, but we could. See, look at how fast that thing is still spinning. It's been a minute. It's been at least a minute. It's huge. This thing is huge and it's heavy. And the heaviness is contributing to why it's spinning so much longer. It all contributes. It's all part of the design. Pardon my throat. It's never coming back. I apologize. If I talk to the point where it doesn't crackle, the frequency is so low that you won't be able to really hear me. But we'll see. We'll see. I'll do my best. And just to be ample sure what's going on here, I'm going to unplug completely the apparatus here. And it is starting to slow down. I should have been timing this the whole time. But I'd say it's been about 3 minutes or more of me talking now. But let's clip this up. We're going to clip it up, power in. Just got to get that banana peel or the piece of garbage, put it in the Dr. Pepper machine. And voila! You just got to get going 88 miles per hour. This thing will go faster than that. So will a DeLorean. So that's 4 volts in, 5 volts in. 0.4 amps. We got 1 power connection, 3 transistors in play. It's a parallel thing going on here, but at the same time it's like a series too. Each one has got its own transistor, but it's hooked in series through the collector in the transistors. It's awesome. I think it's cool. Turn it up a little bit. $12 volts, 2 amps, so 24 watts. okay, then I read it backwards. It says 13. $16,000. I think that's what it said. 16,500. So 16,500 divided by 6. I don't have my calculator right now, so. It's not that much, but let's see, 2,000 would be 12,000. So right around 2,300 RPMs. We're going to get plus or minus a few hundred. That's awesome, man. That's pretty sweet. One power connection, then the collector series for the parallel circuit, 2,300 RPMs. Cool. That's neat. What is that? What does that mean? How do you do that? What Society of High Sciences? Could you explain it more? I don't know what that means. I know what an open circuit is. It's a circuit that isn't closed and being grounded. Okay, if it's not grounded, then it isn't closed. If it's not grounded, it's open. So, how does that work? I'm just asking because I have no idea. And obviously, it's something I need to be doing, so it's just polite for me to ask. All right, gyroscopic pulse motor, here we come. Axial flux, that means this is the shaft right here. Everything goes up the shaft. Not into the shaft, but along with the shaft. You get what I'm saying? That makes it axial flux. Radial flux, this is radial flux. All the magnets are, all the energy's facing the shaft instead of going up with the shaft. Roger, Roger. Okay, now there are two transistors in here. I don't know if this one's firing at all, the second one that I put in there, because the 32 gauge wire is designed to generate electricity from the magnets, and then the diode that I have it connected to the brush with, okay, is facing the plate. Okay, so the electricity is coming from the wires down to the plate, which is a positive plate. Okay, so I don't know what that's doing to it while it's on. It could be messing everything up. I don't know. It does draw a few more amps when it's on, when it's like this, like 200 more milliamps. So it's doing something. Just what is it doing? I have no idea. But when I turn it off and it's only generating power through the magnets, all that 32 gauge wire is going down into the positive plate and then back up through the 20 gauge. But is it doing anything? I don't know. I don't know if it's enough electricity to make the reed switch work. I'm pretty sure it is, because I don't think you need electricity to make a reed switch work. You need magnetism. So I'm pretty sure this is working. The light's not lighting up because you need electricity to light a light. Just saying. Or maybe it is lighting up. I can't really tell. But it was just an idea. And if it has any impact, it's very minimal. I've already run it a couple times, and it is a minimal impact. It is doing something, quote unquote, because the amp draw is going up. Okay, amp draw went up from when I didn't have the circuit together at all. By 200 milliamps or so. Something just came unconnected right there. It just totally stopped moving. There are a lot of connections in this, so I mean it wasn't easy to build by any means. I just knew how to build it, so I built it. Now what's happening with the upper and the lower disc happens automatically with every single motor. If I hooked up these coils to go the same direction like these ones are, and I hooked up these on a Lazy Susan, and I started this up, these coils would move this way, and this motor rotor would move the other way. That's just the way it works. That's the laws of physics right there, in a nutshell. An equal and opposite reaction. That's it right there. Well, I mean, since there's so much more friction on the bottom, it's not equal, which might be like screwing up the laws of nature or whatever. Wow, that rotor is going so fast. All right, let me cut the power. I'm gonna get my watch. $11:36. See now what's happening here? We might be getting a little motion. I think that's from the magnets attracting the cores though. There are cores on this, like big cores. There. Now it's an open circuit. Totally open. It's not grounded at all to, you know, the AC, to the power situation here. It might be grounded some way to the earth, but I'm not even thinking about that, man. That, in my mind, in regards to this, that is not a thing. Maybe later in a different variation that'll be a thing, but not on this one. So what I'm saying is now this is an open circuit. I've disconnected the ground wire. I've disconnected the positive. Totally closed. I mean open. If I hook it back up, it's closed. Now there's a lot of momentum. There's a lot of force in this right now. It's big, it's heavy, it's going to spin. The question is it being aided in any way by the electricity being generated by the 32 gauge wire that's being sent back in to the plate? I'm not going to touch the plate. That disc is moving pretty fast. Now the thing is, do I need to, because after it goes through the system, it goes through the ground plate. Now, what I think I can do, and this is it, man, I'm shorting it out right now. Should have thought of this earlier. We're going to take the ground from all the transistors and everything, right? And we're going to hook it back up to the positive. Now, it sounds like that put a load, a tremendous load of some kind. Maybe not. I can hear it now, though. Probably because it's going so much slower. The frequency is now instead of, you know. But we're going to try that again, except I'm going to put this yellow clip on here way sooner than I did. We'll see, and we'll time it for real. I wish I had my stopwatch, but it's on the phone, so I might get one of my kids to do it. So there are two brushes right now touching the positive plate. There's one diode in play on the 32 gauge, forcing the electricity to go into the plate on the 32 gauge. But won't travel back up into the 32 gauge from the plate. All right, now we're gonna close the circuit. And then we're gonna, I don't know, short it. We're gonna short the circuit now. We'll give it a manual boost. Nope, it isn't gonna gyro. But how long will that spin for? Oh, damn it. We'll call it 1140. It's 1141 now. I don't want to get too distracted because I'm actually trying to get some data off of this. $11.42. So this is going 25, man. There's no way it can't be. Let me get the tach. 17,000 RPM. Well, 17,000 divided by 6. 18,000. Alright, so it spun for 4 minutes. I don't consider that spinning. That's generating very minimal electricity, if any at all. And I don't know what to call it, you know. It's not necessarily motor ready electricity. There's not a lot of amps being generated by this stuff. When I say a lot, I mean you are not going to generate the amps with this stuff. It just isn't going to happen. You can generate some, but enough to power your home? I don't know, man. Show me the scat. Well, that's hot. That is really hot. Sweet. That's weird, man. I got a whole day of sleep. All right, so we did 4 minutes with it shorted out. Now let's try 4 minute or the speed time without it, or coast time. Coast time. Without the shorting of it. See, I spun it the wrong way on purpose. With the reed switch and a definite direction and course, this will work. Every time, pretty much. No matter what way you spin it, it'll go the way you designed it to go every time. And I think the very thing that makes a trigger coil cool is what makes it not work very well for a project like this. I've made it work. I've made the motor run with the trigger coil, but it won't gyro. Maybe it's because the power going through is weak. I don't know. I think a commutator would be good for a project like this. Let me show you something. Okay, so this is virtually the same thing, goes with the same thing, except it spins on the shaft and it has a commutator switch that I'm working on, kind of thing. It's gonna be something like that. No, Gabriel, that's not how you were behaving at all. If you want to explain something to me, you can, but if you're going to sit there and tell me that I'm wrong, you need to leave. That is not explaining something to anybody. Just saying. If that was you explaining that, you're really bad at doing it. Just saying. Peter, you're not doing a good job, man. Get rid of this guy. Because he's still on about the same fucking thing today, man. It's just let him go. I get it. You don't like the way I've done it. I get that. Go away, man. I don't. It's like, wow, dude. Do something else. At least explain what's wrong with what I did, dude. I mean, you totally don't know how to do what you're trying to do, and it's really annoying. Well, because the way you came across the first time, I don't like you. That's why. I mean, we can hammer things out if you want to. I'm all for that, man. Just, or, I mean, angels are known to be they or them, but I don't know. I don't know. My name is Michael, by the way. So before you get defensive, okay, whatever. I am not completely normal. For those of you who haven't caught on to that, I react very, very like, and I mean, Gabriel, seriously, man. Um, I don't know what it was exactly. I can go look it up if you want me to. See, now you're telling me that I'm wrong again, dude. You need to chill out. I'm not going to chill if you don't chill, and that's the bottom line. I mean, telling me that I'm wrong is not being chill, bro. So I ask again, what about what I'm doing? What about what I'm doing? Did you not like the first time? Let's start over. What about what I'm doing did you not like the first time? That might be my total misunderstanding then, Gabriel. And I'm glad you made another account to come and do this. I apologize. Or maybe you never got banned in the first place. I don't know. You said you were going to make another account and come back and reaffirm your position. So I'm glad you did. I wish I could get some data off of this. Does anybody know how to get a meter that can read through the air? I don't feel guilty, Gabriel. I think you were being a. The last time I saw you, I felt like you were being very rude. I don't feel guilty about that. Now, I am sorry if you didn't do that. I apologize sincerely from the bottom of my heart. If I have offended you and I'm totally in the wrong, I apologize. But I don't know. If you're hurt, that's okay. But we should let it go and move on. It's not okay to, it's not, I don't like hurting people. That's not what I mean. But, you know, we should move on from that. You came back, dude. That's something right there. Now, if you want to stick around, all right. You want me to give you the data, Gabriel? I'll give you all the data, and you can do the equations. You can tell me why this doesn't work, or why it does. How about that? Where do you want to start? Let's start with the rotor. It's an 8-inch rotor, okay, with 3 neodymium magnets that are 40 millimeters by 20 millimeters squared. There's a start. Data. And I'll write it down, but I'm writing it down in a list. I would paint a really awesome drawing or painting, but everybody would tell me that I'm doing it wrong. You need to do it this way. All that jazz. So I'm not going to waste my time. Because that truly would be for you guys. Should I waste my time? I'll do it. I'll paint this and make a list and a legend with a paintbrush and oil paint. And then you'll have a visual of the data. Okay, we're going to say 250 turns of coil of 20 gauge and 32 gauge. Okay, we have 2 plates of copper, one for a positive and one for a negative. We have 2 brushes touching the positive plate and 1 brush touching the negative plate. We're going to lift this up just so we can see what's underneath here. A lot of bearings just stacked up right there to get the perfect height. You're not going to get that with a magnet. You're just not going to get it. All right, so look at all those bearings that I stacked up and phalanges to get the proper height for the rotor. Okay, underneath here, if you can see that, we got a toroid maglev. We got the negative commutator brush hooked into this clip, and that clip touches the plate sometimes and slows everything down. But it's the clip. I know what it is. I see it happening. I look under there and I look and I see it. It's the clip brushing against this middle plate right here. Okay, you put this one on first. You make a little lip so you can clip the clip to it. You got to make that lip or it's useless. You tape the lip so that it doesn't touch the positive plate. You put it underneath, and then you put the positive plate on top of that. Oh no. There is a missing. Oh, I think it's underneath. How did that even work? There it is. Ha, I knew I'd find it. When gravity is playing a factor, this stuff is a lot more together. And magnetism, we'll see with all that jostling if it's still going to stay together. Now that shaft is really tight. All right, I got one of these brushes going the wrong way, so. That's pretty solid. All right. So you saw the commutator that I'm using. It's not your typical, around the shaft is going to spin commutator. It's not like that. Both of these discs are on bearings and are free to spin. And the shaft is fixed. I can grab this and just hold it. And everything will still work. Is that better or worse? I don't know. It's different. It's different. It's another way to do it. Do you have one less option? I would say, yeah, you do. You got one less option. Oh, dude. Haha. I'm so focused on, options and stuff. I forgot to raise the rotor. It's all right. Let's do that right now. Ghetto rig, baby. No, let's just hope I didn't damage the transistors with that last spin. Oh, I got it bent. The brushes are backwards. So it's moving a lot slower, but it'll still go. I got homemade jump wires in there with 26 gauge. I use that in a combination with regular jump wires that I got from an electronic superstore. Oh yeah, this is definitely a DC motor. And I have to switch the brushes. All right, I hope I got that right. So I had a little brain fart right in the middle of doing that, and I forgot which way it was before I started doing it. So it happens so much now. It's crazy. I think I got mental deterioration. I mean, you guys don't want to know what it's like to wake up one day and not know who you're looking at in the mirror. You don't want to know what that's like. Although you won't know fear, if somebody puts themselves in your shoes, they will know fear. Just imagine not remembering anything that you've ever done in your entire life. Then it's truly up to other people to remember you. I don't know how to say it. I just call it old timers disease. I've heard it pronounced 1,000 different ways, so I just call it old timers disease. So this rotor gets spinning about 1,500 RPMs. In other words, about, I forget the number, but, and this is only 17,000 double O. My bad, not 31, but 17,000. So the 2,500 is actually pretty accurate. Then you get that pressure, and when you put the rotor on it, you get that extra pressure, and that keeps it touching the plate. This one's a lot less power hungry than my other ones because I don't run it in series. Yeah, that's running a lot better now that I switched the brushes back to the way they were before I lifted it up. Awesome. And yeah, Double O again, he mentioned that the brushes were facing the wrong way, so I fixed that. I hope everybody is building too. I really, really do. I don't mind being a first mover per se in the building regards, and I'm not. Peter's been doing this for years. Mike does been doing this for years. I've been doing this for 2 years, and I'm just starting to, gather what this stuff is all about. Now, we got the Neo ball here, if you can see it. Yes, it is possible. Everything exists everywhere all the time. That includes potential, capability, possibility. You just have to figure out how to do it. And honestly, the way you figure out how to do it is by, well, one is math, and then two is building it. But math is a man-made thing, man. Math, I mean, as far as I know, as far as anybody like really knows, math is man-made. I mean, if aliens made math, or if math was universal, we'd know. I mean, there's only one right answer in math. And I guess that in a way makes it kind of universal. If you build something without doing the math, have you lied? I don't think you've lied. I don't know. I got so much data going on in my head. But I experimented with this ball. I removed the rotor over here in the shaft, and I put the ball in the middle. These coils affect the ball like a lot. So what I was thinking, if there is a three-dimensional shape where the 120s are used and more dimensions that are here. See, this is just one plane. It's three-dimensional, but it's one plane. So it's all on one plane. Okay, so if you switch the orientation and then you make another plane going down and you put the same 120 on this axis or this plane, right? Affecting the ball. I want to build something like that. So what? My mind doesn't live on one plane, bro. My body does. Everything else does. My body, my heart, everything that you can see, feel, and touch. But I understand, okay? And if you don't understand what I'm trying to say, I don't know. I don't know how to help you. So Peter, are you saying that money is the only thing worth anything? Is that what that means? All right, what I'm saying is that if somebody else in the world, okay, is working on something and they haven't told anybody about it yet, at that same period of time across the world, other people will be working on the same thing without telling each other about it. But now everybody like can tell each other about it the next day. So stuff is happening a lot faster now across the globe than it's ever happened before. But this stuff used to happen without the use of advanced communication. It just happened. And why is that? Is it some higher power? Yes, I do believe it is a mental connection that we all share with the earth. So we all know what each other's thinking at any given time on a very basic level. Like all this stuff, I didn't read any schematics. I didn't read any manuals, no instructions, nothing like that. And I guarantee you there are other people building stuff like this all over the world right now. I mean, the fact that there are more people, that plays a factor in it happening faster. You know, there's so much going on right now. But let's see here. I'm just going to show you guys. Yeah, this probably isn't a good idea. So what I'm saying is, oh man, all right, these electromagnets will affect the ball. It won't just be attracted to the iron, it'll be jostling around and stuff. And I was thinking at the proper angles, you know, set up coils just like this at the proper angles at all the points on the rhombicosi dodecahedron. All those points, every single point, and have it facing the ball. Okay? Can we get it to spin, levitate, float? I've seen a build like similar to this that I'm talking about, and it's pretty much the inspiration. It's the only one I've seen. Forget who did it. I think it might have been, I don't want to call a name without being absolutely sure. But if anybody else has seen that, they know what I'm talking about. It's like four-dimensional pulse motor type stuff with a spherical rotor or a magnet rotor in the center, just one magnet. And all you would really have to do is wrap the coils bifilar. So you remove the shaft. Yeah, but energy is such a broad word, really is. All right, so Now this is the first time I had this hooked up with the SG type stuff, so we'll see how it goes. All right, it doesn't look like that's going to work very well. Because as soon as I turn the magnets on and put the reed switch in proximity, yeah, it draws, it's got to be encased completely. And it is encased completely in the other experiment that I saw. Oh, let me get the other bowl if it's just laying around here somewhere. It's got higher. Man. Oh, there it is. Now I could try a steel ball instead of a neo ball. Yeah, that's the problem with that. It's completely attracted to. So close. Look at how close that is to being able to fit in there. But these were printed at different times. And the bowl that goes with this one is, I can't find it. Oh, that sucks. All right. That's okay, though. I'll find that bowl eventually. Oh, it might be going faster, double O. Holy smoke. 900. Thousand. 1100. 3673 divided by 3. So 1300 goes about, I don't know, 1,000 less than this one. I'm just saying the magnetic fields coming off of these cores right here, it's amazing. Especially when you turn it on, it's just awesome. But you got your 3 coils, and then you switch planes. You go X, Y, Z, and you put your 3 coils at X, Y, Z. Boom, boom, boom. Okay? Nice. 5,000 watt. That's so cool, you know? No. mean, I just turned around, Gabriel, and that's what I saw. Creating an electrical charge out, if nothing, without a battery. I agree, but it's not going to run this motor. Show me. You got to show me. You can't just tell me, Gabriel. I don't believe in that. I really don't. And I hear it all the time. This happens when we do this. Show me. It's the only thing I believe in, what I can see. Make a video, my brother. Make a video. Oh no. You say I put that wrench down on this table, that's a bad sign. Show the world, man. Show the freaking world that stuff. And people will replicate it. It'll spread. And if you're going to, I mean, seriously, if you keep it for yourself, it's just a scam, bro. Share it with the world. Because if it's for you, then that's a scam. That's basically the definition of a scam. Bye. Oh, man. See, my memory is not good at all. Did I just put that away? I hope I did. I got a very specific place where I put all these wrenches that they send me. For these little things right here come with wrenches and nuts. I try and keep them all in the same place. I believe that the XT1, OTCX1 is a axial flux, is it not? Kind of. I mean, its basic principle is that orientation, right? Yeah, I'd love to see that, man, because if I could utilize that tech, this it'd start going in a whole different direction, Gabriel. If anybody, not just me, I'm not saying, oh me, oh my, it's not like that. I'm doing my part for right now. I can only do what I can do. I would really appreciate getting a sneak peek at electricity generated from the static, man. That'd be awesome. And I know I keep saying it, but really would. See, it's that force right there that causes this to spin both ways. It's that exact thing that just happened that causes it to happen. And you don't get that with a trigger coil. Not that I've seen. Maybe there is like a size that you like 369. Maybe that will do it. If I can make a trigger coil with ohms of 369, maybe that'll work. you know? Until then, or if you, that might not even work. I don't know. Got to do it first. I only like math when other people are doing it. So 17,000 divided by 6 at 10 volts, 0.1 amps. Or it's more than that. I didn't get the amps. Probably 2 amps. That's awesome, man. This little bad boy is going to be freaking awesome. And then if I follow through with that spherical or geometry, like rhombicosi, or just a regular dodecahedron, shooting at that sphere, man, that'd be awesome to see if anything would happen with that. Or maybe just the triangle, like it is right now, 180, or I mean 120, and then switch to the X, do 120, and switch to the Y, do 120, switch to the Z, do 120. Or, I mean, since it's 120s, you got it, yeah, I don't know, it'll work. I think it'll work doing it just 3 times with XYZ. There are so many more dimensions. There was a wise guy named Seth one time, and he said, if there's a lamp on a table in the middle of a room, and there's a million people in that room, then there are a million lamps in that room. If you think about it like that, your understanding broadens. Everybody's perception of what is in the room is different. Therefore, it's a different lamp every different time it's looked at. You know, that can only happen in that liquid. That can only happen, you can only move forward because you're already there. That's how I feel about it. You can only see what isn't there. No, not 1,700, bro. 17,000. The time? I don't know. I don't know, man. I wish I could delve in and be part of the chat right now. But that, I don't know how I'd set that up, but this 120, yeah, with the, it's just, you know, you got to polarize the whole thing in the third plane dimension, whatever you want to call it. Third part that makes it a 3-dimensional object instead of a 2-dimensional one. Yes, sir. Thank you, Peter. Roughly 3,000 right there. And that's not using the strip in the center, that's using the magnets on the outside. So that's two answers that really add up to be about the same thing. about 3,000, 2,800. That's awesome. Our goal is 5,000 RPMs with 3D printed rotor. Happy Sunday, everybody. Happy Sunday. Thanks for joining. Really appreciate it. Like, subscribe, hit the bell for notifications. I do this stuff all the time. And this moves super smooth. I made a few adjustments and hopefully they stick. They look good. I don't understand why people, don't believe that it's going that fast. I've had some people question. Whether or not it was moving that fast. I guarantee you it is moving that fast. We're going to get the reading on this one again. I think it might be 1,500 if we let it roll. And thank you, Peter, for using the calc, man. My calc's on the phone. Maybe I'll just get an extra calculator for this purpose. $3,000. I'll take another one in a couple seconds. $3,400, 35, 36, 37, 38, 39, 4,200 divided by 3. You think real quick. Let's make it 4,300. I don't know. In between. Thanks, Peter. Wow, man. So it was going 4,300 divided by 3. So that's 11, almost 1,200. I think. Maybe it's 1,300. Wow, and I do believe that that 32 gauge circuit that I have hooked up back into the plate via the diode does work to a certain extent. I mean, what it's supposed to do, its purpose, is to prolong motion. Prolong does not mean perpetuate, so I'm not going to do it. I'm not going to do it. It does mean that it will move for a longer period of time than it would without it. So it's like having an alternator or something that makes your battery last longer, right? And I could make this like totally self-sustaining, like get rid of the plates and all that by putting a battery right here, okay? And hooking all that up to the plate over here, or to the breadboard. Then I don't even need the plates. And I can do that. I will do that. I want to do that actually. Just to see if it'll work. And that'll be 12 volts. I have a small battery pack that'll be perfect for that. And no, I'm not trying to charge another battery, have two batteries and charge each other. This will blow up. This will fit. And this is a lithium ion battery. Nickel metal hydrate battery. Okay, liquid metal. Nickel metal hydrate battery. Okay. This will be our battery, and it charges. I got a charger for it. You plug it into the wall. You charge up the battery. Now, if this is not one of those ones that'll blow up, maybe I'll put two in there, and then we'll see what happens. But it looks like it is, because it's already melting. Gets real hot. 12 volts, Peter. 12 volts. Yes. So that would be awesome, dude. Like totally freaking cool. Let's see if I can put it in here. Face up. Let's see if we can go face up. Now it doesn't matter if the brushes are touching anymore. Oh no. Yeah, it is really attracting. Okay, let's try face down. If we get a little bit more distance and maybe we secure it, it'll work. So if we glue it down, it's still going to have a tremendous amount of pull. It might not work. But we will see. We will definitely try that, like securing the battery. But I just think the rotor is going to be too much attracted to it. I do have a ferrite magnet rotor. Here, let's try that one. See if the armature for the reed switch is in the right spot for it to even work. So I got this, this used to have 3 in it, but I put the other 6 in there because I was using the trigger coils and it worked pretty good. At least as a motor, not as a counter rotating motor. Oh man. So what I gotta probably do for this one is make one of these armatures. It's gonna be a little smaller for a different coil. Position it roughly the same degrees past the coil. And then just plug one in. That's gonna be way too much work. But that's how I would do it. I have 2 reed switches and I plug one in, swap them. But they're hard to plug in because it's just there's a wire and then there's the covering of the wire, and they can both fit in the hole. And if you clip the covering, you're not going to get any charge. So you gotta find the sweet spot. with the connectors and the reed switches. Let's just turn it on. I think it's working, kind of. Oh, did the light go out? Well, there it goes. It's just so much more voltage is needed because the magnetic strength is so much less. And it's like a perfect spot, like right there. I'll just turn it on. And so the reed switch will still operate without the light. Oh, man, I am a freaking idiot. Can anybody describe to me what's going on here? And why I feel stupid? Alright, now we'll see. Yeah, it catches up with you, especially with age. If you don't take care of your brain. And no, I'm not just talking about drugs, I'm talking about like the way you eat, even, is very much contributed to how well your brain functions when you get older. So we'll start like that. So we need a smaller armature. That much we can kind of gather from it not functioning. Used to be about right there. And the only thing I can describe as to why that happened is my memory is totally gone. So maybe I should start writing some of this down, I guess. See, there's enough magnetism to get it to go. I need to get those magnets out of there and have it be a 3-banger again. 1 amp, 13 volts in. We're getting a slight rotation at about 17 volts, very slight motion. So I would say, no, this rotor is currently not going to make it work. I'll get that armature printed out and we will see. It's got a, I can't be holding it there. It's such a small sweet spot that I can't do that. I shake too much. But I like the rotor, I really do. It's, if we get that spot, man, it's going to be something special. Yeah, Paige. Paige! Let me get her, guys. Let me see if she can be the cameraman. We'll spice it up a little bit. Some entertainment. Hey, Paige. You want to be the cameraman for a minute? All right. Cool, thank you.
Yay.
Here she comes.
I get to ditch Jax and do this.
All right, we're gonna fasten. I'm gonna make sure these are in here. Yeah, those are good. All right. Huh. And the light appears not to be working right now, which means it has, the light may have blown out, but as you can see, the switch is still working.
Hmm.
So what's up, Paige?
I was just chilling with Jax.
You want to go chill with Jax?
No, I said I was doing that.
I'm just asking. So 10 volts, 0.5 amps.
So it's really just been Noah and Peter Hall effect in the chat.
Well, no, but yeah.
No Gabriel.
Yeah, Gabriel's been here.
Oh, he did?
Yeah, he's okay though.
Okay.
He was one of the other people in the chat.
Hmm. It's funny.
Just be careful. You should move that stand back behind you, move back and back up a little bit.
Why? Because it's going so fast?
Yeah, you need to turn around and do it right. Turn around and do it right.
It's fine.
No, turn around and do it right.
No, I'm done.
You're done? It's gonna, the table's gonna fall over.
Come here, Tiggs.
Oh man. Yeah, just stop touching.
Well, don't leave it unattended.
Look out. It's a catastrophe waiting to happen right behind me. No, it's not. No, it's okay. All right. $54, $5,500. Woo! All right, I'm gonna cut the power. That thing's going so fast, and you know, at first I was skeptical that, you know, if it counter rotated, it would increase in speed. I was skeptical, but it happens. It really does. Not only does it increase in speed with the reed switch, but it increases in frequency because the counter thing is happening. The energy is countering. Um, it's probably because the way the magnets are facing, there's a lot of things in play here. It's monopolar. It's not a bipolar thing. Uh, all the magnets are mono too. They're wrapped the same direction. They're facing the same way. All of it's the same in that regard. 250 turns per coil. All right. So, right on.
Streams have been a little low recently.
What does that mean?
Not so many people.
Probably time or my attitude. I don't know what it is. Why you bring that up?
Because I've just been noticing it.
Yeah. It's kind of gone. It went from being really, 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 really good, and I probably ended that one too soon.
Oh yeah, they're all at church. Isn't it Saturday?
Sunday.
It's Sunday?
I'm pretty sure it's Sunday.
It's Sunday?
Yeah.
Today went by a little, I mean Saturday went by a little bit too fast.
You just back that up a little bit. Those magnets are really strong. Thank you. And there's one right here.
Mm-hmm.
Yeah. All right. So what's going on, girl?
Yesterday went by too fast.
Yeah.
It feels like Saturday.
Yeah, it did. Yeah, it did. I really appreciate you holding the camera there, Paige.
Mm-hmm. Especially because I was about to put something in the microwave.
Well, I mean, like, if you want to go, just get the stand, put it back in the stand, okay?
It's gonna take too long.
All right. That's cool. I don't know what to say to that. You can usually cook food in the microwave pretty fast. And I know you're talking about the stand, but
I sadly don't go to church anymore. I used to.
yeah, when her mom moved out and took them, they went to church with their mother's boyfriend. What was the name of that church, Paige?
Columbus.
You're a big girl, Paige.
I still remember that very vividly. I had a friend. I think her name was Addison. It's hard to remember. No, it was not a Catholic.
Her mom's Catholic, though, or was raised Catholic.
Really?
Yeah.
She was raised Catholic, but that church wasn't Catholic.
No, it wasn't a Catholic church. It's a New Age church.
Yeah.
Anyway, when that happened, I got really into doing this stuff, and it's kind of been there for me, just like my kids have been there for me.
Mm.
Oh man. Okay. Yeah, Paige.
Yeah.
Should probably go back.
It's the view count, okay?
Just put the phone back on the stand.
Can you go grab it?
Yeah, I'll get it. You. All right.
There we go.
Cool. Okay. Go have something to eat, okay? She's an awesome kid. She's in too much to the hype, though. It doesn't bug me that there are fewer viewers at the moment. Not even a little bit. And I don't know. She seemed kind of upset. I'm going to talk to her later. See if I bugged her about anything or what's going on with her. She was playing with her friends before I asked her to come over and do the camera. And ultimately, you just get banned. Yeah, I don't know. She kind of felt to me like she was in the zone. Like she even said she felt like she was still in Saturday. So I'm going to have to buy some more reed switches, but that's okay. $5,400 divided by 3. $5,700 divided by 3. 58. $59. 15.6 volts in, 0.3 amps. 6,000 divided by 3. That's 2,000 RPMs right there, isn't it? $2,000 on the big rotor. That's freaking cool. So I encourage people to enjoy themselves on my channel. Don't diss on me though, I don't like that. You're gonna have cross chat, talk about stuff. I want to be able to look back on the chat and actually learn something, you know what I mean? Talk amongst each other. I encourage that 100%. It's pretty well balanced, man. That's 2,000 RPMs. It's riding pretty high on the shaft. And really the only thing that's holding this in place is a flange that is screwed into a pegboard. So when I say it's well balanced, I mean exactly that. It is well balanced. It's not perfect because it is shaking. But 2,000 and having it only shake a little bit is pretty good. Especially when you're using Tinkercad, which is not professional. But it's close. It's really close. It's all really close. So my theory is, and I'm pretty sure this is a law, like equal and opposite reaction law. But if you unhooked and put on a disc any stator of any pulse motor run by a reed switch or a Hall effect sensor, I don't know about the Hall effect, but it'll counter rotate every one. I don't know about trigger coils, and I'm not sure about Hall effect sensors, but I know a reed switch will counter rotate every time. You don't have to do anything. You just have to hook it up so the circuit makes sense and it'll work. There's a lot of counterintuitive stuff that I bumped into, and just to clear this up, the Schottky diode on the SG circuit goes emitter to collector. And then that energy gets reused. Emitter to base does not do that. All it does is trigger. If you want it to be auto triggered, then you put it to base. If you want that spike to be used in the drive, you put it to collector. It's pretty straightforward, and that's what I thought to begin with. And I'm like, it goes to the base. Like, what does it do? What does it do when you hook it to the base? All it's going to do is help time your motor. It doesn't actually add any energy to the drive. But if you're timed good, then it increases that. Everything works out. So I guess maybe you do it both ways, or maybe the light is what I'm talking about. Collector to emitter. But they said the Schottky diode, and this is chat that I'm talking about. They said the Schottky diode goes collector to emitter, or emitter to collector instead of emitter to base. That's what chat said. So I just wanted to clear that up. And that's how I build it now. and it works pretty good. I would do both, emitter to collector and emitter to base, because then you get it timed and you get the electricity to go back in. And how do I know it works? Is because I built it that way, and it works. I broke all the rules and it worked. Because I know that's a resistor that goes across the collector and the emitter is a resistor, which is the light. And I get that. That works. But when I asked chat, where does the Schottky diode go in the SSG circuit? That's what they told me. It goes collector, or emitter to collector. I go, which way does the cathode and anode point? Cathode points to the collector, anode points to the emitter. And that's the way I thought it should go in my head. Like, what is it going to do when it's attached to the base? It's going to trigger the base. And the base basically closes the circuit. The base is the switch that closes the circuit, okay? It allows the collector and the emitter to connect. If you got a reed switch in there, or a trigger coil, you already got your stuff timed, so you put it in the collector. And then that energy goes back. Me personally, I'd do both. I'd have it be extra timed, and I'd have it go into the collector for extra energy. You get that spike going through when it collapses, and you send it back to the collector so that you can use it. Especially if you're already timed. If you're already timed, then you put it in the collector, man. You don't. That's probably why, I would spin it and then it would stop spinning, even though it was triggered. Because the timing was then off with a reed switch or a trigger coil and the base being triggered by the SG. I think let's talk about the batteries, because I really do want to hook a battery up to this thing. But I also, if I'm going to hook a battery up to it, I want to have a switch, like just an on-off switch. Because as soon as I hook this on, turn it on from a battery, even with the toggle switch, man, I need to have a remote control. That's what I need. So we can work on building a remote control for this thing if I'm going to run it on a battery, because I need to be able to turn it off. Oh, no, because I'm going to get really excited about this. I'm going to hook a battery to it and I'm going to turn it on. And I'm going to probably end up losing a finger or something trying to turn it off. Be sweet. Let's do it. But then again, I think these magnets right here are going to mess with the battery hardcore. And let me show you the smallest SLA that I could find. Is this, and this weighs 5 pounds, man. This is not going to go on the rotor. This weighs like 2 ounces, and it's going to be what goes on there. All right. And then I guess I would run just the one transistor And I would run the 20 gauge strands. Bada boom, bada bing. Just let me recall where it starts. Oh, that's right. You just take the brush from the 20 gauge brush, which is right there, and you just pull it up. You get one of your connectors and you connect it to the positive end of your battery. I'll have to, I mean, that little nub right there on the battery is not going to be big enough. I need to open that up a little bit. I'm more worried about doing that. That is a very precise clip right there. I mean, that is extraordinary, and I wouldn't be able to see it. So it'd be like feeling my way through that. Oh, just thinking about that is not cool. All right, so the positive would go there. And then the negative brush, or not the negative brush, but this part that's connected to this clip right here, unclip that and clip it to the negative of the battery. Boom, I just did that in my head. A total like conversion, a transformation of this thing into a not self-sustaining but totally untethered machine. Right now it is tethered to the wall because the power is coming from the wall, my DC power supply over here. For those of you who are curious as to how I'm running this stuff, if there is anybody that's curious, got two DC power supplies right over there on the end of the table. Now I have a PWM, but of course, I mean, I could do it with my finger, no problem, probably. Stop it, I mean. Well, it depends on how fast it's going. Get a PWM with a forward reverse switch. On the forward, turn it up. This is a half a turn pot right here. So, I mean, if I was to hook this up and use it as a pot for resistance, it would not be functional really, because I would turn it and it would be like all the way up at half a turn. So that won't work. When you're trying to narrow it down to 1,000th of a hertz or something, having a half a turn pot doesn't work. So we're going to use this as a pulse width PWM. Speed control for the battery to this system. Right? I mean, I have to change my wires a little bit, but it's quintessentially the same thing as having a switch. I mean, I have a switch. I don't know where it is right now. It's just a little metal, and it'll be 12 volts in. Where would this go? I mean, curious as to what? As to whether I'm going to rip space-time open right now? I doubt it. I'm probably not going to do that, but we'll see. Here, if I'm going to do that, let me unhook the 32 gauge strand because it makes the amps go higher. So let me unhook that. We'll go straight 20 and we'll turn it up because it's parallel. All it's doing is adding. It's not subtracting like a series would. It's adding to the damage All right. Huh. Let me just turn it around and see what happens. So now the energy's coming up from the plate instead of going down to the plate. This will be a true parallel, and we'll see how high we can put it without going too high. I mean, I do have another pack of transistors, but I'm really trying to turn over a new leaf with the transistors. And the reed switches, but the reed switches are coming more slowly. I think I blew something right there. Something went. Well, it didn't blow, it just lost its teeth. Maybe I'll have to unhook it altogether. 32 gauge. Or maybe I had it right. We'll flip it back if it does that again. 0.4 amps, 10 volts in. Shaft is swaying a little bit. Twelve volts, 0.4, 0.3. 0.2. Yeah, we got it. Fifteen in, 0.2 amps. So I think we're getting more speed the other way. 4450, 4500, 46. We're at 15.2 in, 0.2 amps. 48. All right, let me turn it up. 16.5, 0.4. 17, 18, 18.3 in, 0.4 amps, 0.3 amps, 58, 59. 6,000. Increasing very slowly right now. 19 volts, 0.4. 20 volts, 0.3, 0.2. 63, 6400, 6400. Divided by 3. 6,500 divided by 3. $22 volts. 0.2 amps. 6,700. .25 volts, 0.4 amps. This is max 7,000. Divided by 3. That was max Q right there. We probably could have got some more, but I turned it off. So we went all the way up and nothing really happened. I mean, we got going up to 7,000 divided by 3 RPMs. But that was 24 volts in. If we put a battery on there, it's only going to be 12. Will it ever get going that fast on 12 volts? Maybe. We get rid of the brushes, maybe. I'm going to lower that shaft a little bit, see if we can't get some more stabilization in there. And I'm going to unclip this power, and I'm going to short it out. And I'm going to plug this one in. The flux capacitor. Good name, man. I think it looks like a flux capacitor too. So what I'm going to do is I'm going to rework these coils. I'm going to put 6 times more copper on there. So there's going to be 12 layers instead of 2. They're still going to be smaller, thinner, but there's going to be more copper there. $28.97. So I say they were pretty much going equivalent speeds currently. This one will probably end up going faster in the end, but this one right off the bat will go approximately 3,000 RPMs. Well, this one takes a little bit of time to build up the speed it needs. In order to lower that shaft, I'm going to have to take the whole thing apart basically. So I'm not even worried about doing that right now. Whew. But I will, I got to. It needs a little bit more support, and I drilled a hole through all the way to the ground. So, you know what I'm going to do? Since the gyro works on like 0.2 amps when it's sped up, try running both of these at the same time. And let those amps go down a little bit. So 2.1 amps total, 1.9. I knew that was going to happen. That was 17.5 amps. Haha. Shit. But I do feel like they were helping each other out, kind of. So if there's a way that we can, like, put a resistor on that together circuit, that would be awesome. I don't know how to do that. But that ended up pushing like 0.2, or no, 2 amps for both motors is what really ended up happening there. And I gotta remember not to push on this because I just can't do it. See, it's just placing it that allows it to work. Because I can push it all down because it's on a maglev altogether. See, it's that glue on that clip that's just touching the thing just a little bit. And when you just place it, it doesn't happen. All right, that is working. Still working. I have the two motors connected together physically via SG through the clips on the plates. We could do that too. I mean, like have the SG of this motor or the collector extension of this motor run this motor and see how that works. I just got to make sure this one's still working. That was 17.5 amps running both of them. Yeah, this switch is blown. It's all right. I gotta buy more switches. But this thing is like solid. This one is solid. This one or the coils are experimental. So I've never built coils like this before, and they do push a lot of amps, like a tremendous amount of amps. And I currently do not have another reed. I have lots of reed switches lying around. I don't think any of them work. Haha. So I gotta buy another package of those. The ones that I like to use and that fit and suit my purpose cost $30 for a package of 10. I'll use other kinds, but I'm not for my projects. I won't use anything else. See, and I just pushed on that, and it'll mess it all up, just pushing on it like that. I mean, I can't grab it. These kind right here, I like these kind, but I won't use them for my projects. Maybe I'll use the, because you can't clip it like it's clipped right there. There's just so many things you'd have to do differently. And maybe I could or would. Maybe I could use one of those. So something like this. And I'll use two clips, a clip on each side, and just be able to switch it out like that. Might even be a lot easier. And just put it on. That one actually still might work. I hear it clicking. So I'll actually have to test these. Might use one of those. It would be a lot cleaner. It wouldn't have the wire that's attached. But then I wouldn't have, freedom. Basically, I'd have to make my own wire for freedom. Freedom to move it around and stuff. Because what I'm talking about is like once you put it in the clip and you put it in the other clip, it's going to stay there. You got to get the right positioning. I mean, the same with this clip, I guess. They're pretty much the same. This one might be a little cleaner in the end. It's hot, man. I'm sweating. But when the two motors were running together, did you hear anything like increase? If you could hear it at all, like as soon as I started this one up, it started immediately going to 2 amps instead of 0.2. So that means that 2 amps are going to this motor and 2 amps are going to this motor. Doesn't it? Or does it draw individually per transistor? I don't know. When you combine them together, there are so many variables that it kind of makes you want to do them separately. I mean, power supply wise. I got one input running all this stuff. And I do feel like I've fried a transistor even at this point, running both of them. because when I turn it on and it's plugged into that one, the amps immediately start to climb, which means that the circuit is perma-closed. Which means it doesn't mean that the reed switch, it could mean that the reed switch is perma-closed, could mean that, but it also means that a transistor has to be perma-closed. Or it stops at the transistor, at the base, or no, at the collector because the base is closed. But the base isn't closed because the reed switch is closed, perma-closed. 17 amps, 17.5 amps, and whatever voltage I had going through there. This is probably fried shut. So whenever I turn the power on, it's immediately going to trigger the base. And therefore, yeah, you know how it works. But this axial flux, counter rotating DC pulse motor with wedge-shaped coils of 250 turns, bifilar of 20 gauge and 32 gauge. This is essentially a parallel circuit of the 20 gauge and the 32 gauge. And I know you're not supposed to do that because it makes the motor kind of fight with itself when you have different gauge drives, but I did it, and it works pretty good. 7,000 divided by 3, please. Here, let's turn it down to 12. And it'll be 12 with the brushes. In between 12 and 9, because once the battery runs for a little while, it won't be pumping 12 volts anymore. So this is 12 volts with 0.2 amps. So I guess it could run for quite a while at 0.2 amps. $4,500. 46. But I don't think 12 is enough to perpet. Well, I mean, we won't have the brushes at all. I keep forgetting that. Because with the brushes, you got to run it at like 15 to keep it going, or the friction will overcome 12 volts. $50, $55, $55, $74. Whew. Kind of want to stop sweating here. That'd be awesome. Let me turn this on. All right. Whew. All right. And I do have 2 of these. I actually have 3 of these batteries. Battery packs. They're 2000 M.P.H. 1 8 volt, 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 1 8 So that's 2,000 milliamp hours. I guess that's what that means. The only thing that's a problem is how magnetic it is. And the fact that I can't turn it off once I start it unless I put my finger on it or stop it manually. And then I'll have to unclip it. Well, I'll stop it manually, take the rotor off so it'll stop spinning. I'll have to do something cool like that. Right now it's working off a DC commutator plate to the wall. Two plates, one positive, one negative. And I will have to glue this battery down. I will have to glue it down. And actually, I kind of want to charge it real quick, make sure it's charged. Hey, what's up, everybody? Welcome. Sure, there's a lot going on. So this is the T-Energy battery charger. We're going to do 2 amp charging. See, it's kind of the same idea as a cap dump right here with the AC power. So it is charging. It was not full. Do you think I could strip those wires that are connected to the battery without getting shocked? I think I can. Oh, I don't know math, dude. I failed algebra like 4 times. I'm not proud of it, but yeah, I don't do any of that crap. And you can't tell me that. You do the math and you'll find out that it's probably pretty close to being right. I mean, if you know how to do it, go ahead. I'll give you the data and you can do the math. Sound good? Math is not the data. Math is what you plug into the equation. Data is what you plug into the equation to do the math. That's what data is. Information. And I guess the answer is information too. But there's a lot that goes into getting the answer, I guess. And we could work together as a team and get it done. Or we could just sit there and bark at me. I don't know. Alright, so we have an 8-inch rotor. From the shaft, it's 3.5 inches. Roughly, it's a 1/2 inch hole in the middle. Got 40 by 20 millimeter neodymium magnets, N52. Take the hood off. Taking the hood off, we got 250 turns of 20 gauge and 32 gauge. Bifilar coils, wedge shaped. Axial flux goes with the shaft. Shaft points up, coils point up. Alright, we got two commutator brushes, one touching a plate in the center. Hopefully you can get this shot. You can see the plate on the toroid. That's as high as it'll go. So there's two plates, and they're set up so they're not touching each other. The negative and the positive are clipped. The positive is the little one in the middle. No, the positive is the big one on the outside. The negative is the little one in the middle. There's one brush for the negative, two brushes for the positive. It's a standard hookup for the transistor. You got, except for the reed switch is hooked up to the transistor as well. You got your base, your collector, and your emitter. And you got the negative of the reed switch plugged into the base. You got the positive of the reed switch plugged into the collector. So base, collector. You need a, I could probably work it through the emitter. I never tried it. Works really good going through the collector. So, negative of the reed switch goes into the base to trigger the base. The signal that goes out of the reed switch goes into the base. The power goes into the reed switch or the, whatever's going to make it connect it. This one I go by the light, and I guess it would work either way, but I mean the collector or the emitter for the positive end of this reed switch, or the brown wire. Let me get another one and show you what I'm talking about. Okay, it's a two-wire setup. You got a brown wire and you got a blue wire. This is the negative, this is what comes out. This is what goes in. Okay, the collector has got that sharing, the SG thing. So you put that in the brown one. And then the switch will then send a signal out the blue one. You want that signal going out to touch your base. That's what you want. Then the collector is hooked up to the end of the coil. The beginning of the coil is hooked up to the brush that touches the plate, or the positive end of the battery. Okay? That's what that does. The brush either touches the plate, or the brush twirls around and gets connected to the positive end of the battery. Okay, now, the negative, you can have as many transistors as you want, the negative can all dump into the same situation. But I believe you need alternate power supplies to run a popular or a proper parallel. You're going to need different batteries for that. And we just kind of proved that with my power supply. For a stable thing, you need different power inputs. You can run it with all the same input, but it's not as good, I would think. I haven't done it the other way, but I'm imagining that it would be better having two batteries running a parallel circuit instead of just one. You can, like I said, you can do it either way. And then the emitter is hooked to the negative, and the negative is hooked to the plate, or the negative end of the battery, and voila, you got it. Still charging that battery. Oh, that's it. Ha ha. Damn, I do that a lot, especially today. Oh, I think I was gonna just hook up the battery right then, but it's half dead, so I'm charging it. I'm not charging it with an SG because it's a lithium ion battery, I'm pretty sure. And I don't have a cap dump. I'm gonna need to get a cap dump if I'm gonna run it like that, like legit, instead of putting my own twist on it. So this is approximately what we'd be getting out of it. I think we get more out because there won't be the brushes scraping on the plate on the bottom. All that stuff will be encased in the rotor. Basically not encased because it's open, but you get what I'm saying. It'll be resting on the rotor. Hook to a battery that's on the rotor. Boom. Everything will spin. Spin like it's supposed to. Still charging. Look at that baby go, man. The power is off. It is freaking off, and that thing is off to the races. That's a lot of momentum there, folks. Now I just want to discuss for a second the Utron or Utron and why it has to be propped up on that angle for it to work effectively. Why it has to be on 45-degree angle for it to work right. And it's all about surface area, right? If you have it straight up and down, it's only going to affect the edge, or mostly the edge, because it's going to hit the edge first, right? If you tilt it to the 45-degree angle, you're hitting it on the square side, and all this gets into the push, and you got way more surface area for the pushing. So it has to be on a 45-degree angle, and therefore I need to know what the holder is called so that I can find a schematic for it and build it. It's like, in my opinion, it's kind of like that. You build it and it looks like that, and then you separate it and it automatically makes a 45-degree angle. It's perfect. It's called like a Toron or something like that. I need to know so we can move forward. I could probably ask Chad, but yeah, I'll ask Chad. I haven't asked Chad yet. But having that particular shape, it's a shape that when you separate it, it makes a 45-degree angle for one of those Utrons to basically rest in. I put an aluminum plate with like a little puncture dot in it. And the key is to have that spherical angle or that cone-shaped angle in the aluminum plating be a wider angle than the tip of the Utron, so it'll rest in there just at the tip. Just the tip, right? That's the whole point, man. Just the tip. Don't get greedy. And then it'll spin like phenomenally fast because it'll be in there, but it won't be There won't be any of the surface area touching any other part. But it'll be resting. Just, you gotta trust me on that. It's gotta be a little bit more obtuse than the angle of the Utron itself. Then you only get that little tiny point, and it works really well. It's gonna be super duper, like impossible to do. I don't have like a leather punch that looks kind of like a shotgun shell maker, you know, like that. But could put a hole right where I need it to be. You just hook a leather punch up to the shotgun shell maker, and voila, you get your little hole that has a more obtuse angle. Because you can calibrate those things to like put the exact amount of pressure that you need. You just put a little needle. You're not trying to poke a hole in it though. You're just trying to make a dent that has a wider angle than the Utron. That's all you're trying to do. Then you put it on the toroid or whatever, and voila. It spins, and it spins fast. And I got a little empty sphere in the center of this thing. I printed it out that way, a little empty sphere in the middle. So any of the air caught in that empty sphere, if it gets spinning fast enough, will ionize. And I hear it will cause it to spin even faster. There is a small vacuum in there. It's air that is caught in there. It's been printed and sealed inside. Cool. Cool. But am I like trying to go back in time? Not really. Am I trying to do any of that? No, I'm just curious about this stuff. It fascinates me. It blows my mind. All right, we are charged up with the battery. I'm a little nervous. I mean, I have to fix the shaft before I end up doing this completely. I mean, what would it be if you couldn't take it apart and put it back together again and have it work? I'd say it'd be a piece of piece, right? I've taken it apart a lot of times, and I hope every time I put it back together that it will stay together. Well, I don't really need to do this. Let's just do this. Positive. I need a longer wire. Now, curiously, as I look for a place to put this down, I don't know, that wire might be long enough. Hmm. Instead of like shocking myself to death, we're just gonna do it the old-fashioned way. It's almost like it's designed. All right, the positive is hooked up. Oh my God, I can't believe I'm doing this. Mm. My throat is so dry. I'm gonna have to get some water. Oh, seriously, man. All right. Now, wow, that's spinning so much better already. Look at that. I didn't even like, and it's gone. All right. Now, while we're waiting here, as I hook this up, put some glue down there. All right, on the diagonal, hopefully that'll hold. Now the weight is a little unbalanced because of that battery. I think maybe even having two batteries in there might. All right, and now take the negative. And we will hook up. Yeah, we're gonna get these safety thing plastic on the clips before we do this. And this might be frustrating for some people to watch. Oh, we got it on the second try. That's awesome. Now it shouldn't work until I put the rotor on, but we're just gonna play it safe. That'd be awesome if this thing just works like that. That would be cool. Now that is juiced up. Let's see what happens. Oh man. All the clips, but the light was on. The light was on. But all these clips are magnetic, so we gotta glue them down. Give that a second and we will see. If it works that way. Damn. All right. Clips are not going to work. Not going to work. Because they're magnetic. These clips won't work. I might be able to use the bigger clips. You could try that. Is there less magnetic or not magnetic at all in comparison? might have to get a little bit longer wire for doing this, because it's like cutting it a little shy here to get a good connection. All right, boom. Now, but I don't wear my shoes. All right, let's see. That's a load of wire right there, but let's see. It's really simple though. Just follow the dots. All right, we cannot use clips. It takes it too high. It takes it to another level. So I gotta make connectors. All right, so that's what I gotta do. Gotta make those ends on the battery a little bit longer, and then I gotta use like these. Let's see if it works out after I take these off. Because the light is turning on. This thing will work completely without a commutator. We just have to get it so it doesn't grow. And the measurements. I'm a dumbass. I'm so dumb. Haha, man. Alright, we're going to hook that back up in a second. I wish I would have turned around. Somebody probably noticed this. But remember when I was talking about being able to put it back together? Well, I forgot to put it back together. Just stack these bearings and flanges up. Let's hope those transistors still work. Praise God, please. Still work. See, I'm just forgetful. And even if I wrote it down, I'd probably still forget that. Wow. Man, we had it. It was... Make sure that's the right one. And hook it in, hook it in. Positive hook up. Are we ready? I mean, geez, I am so sorry about that. This would have been done. You'd be watching it move right now. At least I'm that confident that it's going to work. It could totally not work at all. But now that I think I've worked out all the kinks, I think it'll work just fine. Here I am trying to twist the shaft. Oh my god. All right. There is a clip that is dragging ass that we don't even really need anymore. I might put another bearing in there just to give it a little bit more clearance. Hopefully it'll work just as good. Yeah. Hold on. All right. All right.
Your life for 3 hours?
Maybe.
How long is yours? 3 hours.
Oh, that's amazing. Thanks all for hanging in so long. This is cool. We're doing it. Battery operated.
Are you gonna do 4 hours?
I don't know. I don't know.
Just saying, no one's gonna watch this for 4 hours. Maybe I'm gonna. I mean, some people might do, but that would be a lot of watch hours.
No, there's like no clearance for that clip. So I had to remove it from where it was and attach it somewhere else. I think this is now a battery operated machine. totally not connected to anything, man. This thing is running not connected. Woo! That's awesome. If anybody is watching, I just basically disconnected it from the power supply. 1900. It's got a battery. It's running on a battery, of course. 1900 RPMs divided by 3. 2000 RPMs divided by 3. Twenty-two. Oh, look at that. Oh, I went out. Oh, there it is. Well past that now. 2318. That's awesome. Huh. That was really cool, man. And that's how you stop it. You just take it off. Take the rotor off. Woo! That was sweet. That was freaking cool, man. So I think I'm going to do the shaft thing now that it's all hooked up. I just got to lower it a little bit. Alright, let me check the underneath. Alright, cool. It's sticking through the bottom. That should help a little bit. You know, I could put one of those flanges on the bottom and screw it in.
That would make it really tight. Oh, it's moving right along, man. It's about battery operated now. So we're just gonna take off the copper and the power supply all together. We got it on a battery. Battery operated, baby. So we are going to levitate it with the toroid magnet. Oh man, I hope this gets back on there. I mean, good Lord. There we go. Now there's no commutator to worry about now. All right. So that should reduce the friction on the one side. We only got 12 amps going in. I'm not going to forget this again. It's not really about what it is that's being stacked, it's about how high it's being stacked. And I'm going to prove it. Man, something feels like it's getting chafed about the pole on the tip there. All right, we got a lot of contact. It's all about flattening that stuff down the right way. So this could go over here and down in here like this. Gotta find, there it is. There she blows. We got this. I'm gonna add another I guess that's 3/8 of an inch. Let's see what happens. Either we're going to be out of contact with the reed switch or it's going to work great. Let's go. Alright guys, battery operated gyroscopic pulse motor. 12 volts. We're just going to let this run for a while. $2,800, 2,900, 3,000 divided by 3, so that's 1,000 RPMs. Three thousand 330. $3,500. 36. That's one way to do it. Just take the reed switch off. Whoo! That is awesome. That is freaking awesome, man. No, the power supply is a 12-volt battery. Whoo! Thanks, Peter. Thanks for all sticking around, man. This has been great for all of you that have stayed. This is truly amazing. Went from an idea to manifesto right here on the live stream. That's great. All right, I'm gonna get some water. I'll be back. Alright, so granted, it kind of looks like crap. Got all the wires just kind of hanging there. And for right now, that's okay with me. It's awesome in my mind. The battery operated. Counter rotating. Motor. Let's hook up the reed switch first. If anybody just tuned in, This is a battery operated counter rotating axial flux DC motor. Listen to that like diesel engine sound, man. 12 volts in, 12 volt battery. I don't know, it has 2000 M.P.H, so it'll go for a little while. I got a space for another battery, and I could hook up the SG thing if SG used batteries that could fit on here. Unfortunately, they don't. We were losing. See, it's not, none of the wires are bolted down. I don't want them to get caught on anything. Need to put a little bit of glue. We can do that. Just one little dab. This will be easy to take apart. All right. I'm probably going to get real nonchalant with this thing when I turn it on in the future. Right now I'm being extra cautious. Because it does not have an off switch. It does not have an on-off switch. I want to reiterate that one more time. This thing does not have an on-off switch. And I reckon every single motor will do this. Kind of rotate if you unfasten the stator. And you hook it to the shaft. Right on. So I say we're going to give it like 5 minutes. And then I'm going to tack read it. And we might give it a call of the night for now. Yeah, milliamp hour, the M.P.H. So I'm thinking this is like 200 milliamps, or yeah, 200 milliamps per hour. So I'm thinking it'll last for 10 hours. $3,000. You are getting a slight 3,314 RPMs divided by 3, of course. Like 1,100. At 12 volts, man, that's pretty good. Pretty good, battery operated, 34. But as you can hear, it's still rubbing. Still grinding on that. Just one thing now, though. That's pretty cool. It's that red clip. Oh, man. All of my bearings got stuck to the rotor, magnetically, of course. I don't know where they all went. Haha. Yeah, really not funny. Are they hooked to the bottom of this? No. Because that was like the perfect height. There it goes. Let's see if I got them all. Nope. There's another one. That looks about right. Put one more on there. And we'll glue down that one clip. And then we'll let it go because I don't want to give it our official test run. We're having like something bumping that's not supposed to be bumping, you know? We do want to hook the reed switch up first. Man, this is when it's like really free moving, it's kind of difficult. There we go. That should work. Alright, here we go. It's time unencumbered. Let's do it. So much better. Hear that? So much smoother. What is that? That must be the motor. I don't see anything touching. Must be the reed switch. Alright, so we're gonna go for 5 minutes. We'll see how fast we can get. It'd be nice if I could fit 2 lead acid batteries on here, but it's not going to happen. Unless I can get really, really small ones. That was 2,000. So it's not, the battery may already be draining. $2,200, 2,300. I'm pretty sure that if you don't have like a battery charging a battery type thing, that the batteries will run out really fast on a pulse motor. That's just what I'm assuming. That if you don't have the like the total SG package hooked up, your batteries are gonna die pretty fast. 2,500. Yay. Alright. So I that's the first time I ever recovered a stream. Yeah, man, that's the first time I ever resumed a stream after the phone died. I think that's pretty cool. So we're gonna wrap it up because it's been almost 4 hours, and we are going to wrap it up by running this thing. Apologize for the lapse in entertainment. I'm a lot more chill today than I was yesterday, though, I gotta admit. Yesterday was a bad day for me. And look at that, man. I did that in a daydream, standing here on a live stream. Boom. Not like, I'm telling you, if you know how what's happening, you can put it together like that. And it's simple. Like, run into somebody who's running into you. And you both bounce back when you hit each other, right? Or you that force gets administered to you in pain if you don't move back. Put it that way. So if you go head-on collision and something doesn't give, that's a lot of pain that you encumber. So something's always giving, is what I'm saying, when you push. Over and over and over again. When I think about it nice and hard, that description doesn't quite cover what's going on here. It's an equal and opposite reaction for sure. But this is all being done by magnetic forces. 3,000 divided by 3, 1,000 RPMs. And there is quite an air gap there. Like an air gap the size of, the Grand Canyon, man. It's a big air gap right there. Compared to what what I've heard is a good air gap. This is even a pretty nice sized air gap. It's like a centimeter. We're talking millimeters here with like the really nicely engineered motors. So cool, man. But I mean, for proof of concept of counter rotation, and I'll say this again, I think that all the motors want to counter rotate. All of them want to move. The stator wants to move in the opposite direction that the rotor is going in. And then when you hold the stator down, I don't know, man. I think it moves faster when you don't hold the stator down. I think even though it's not moving at the same speed as the rotor on the top, because if that ever happened, I think this thing would start to climb and it would never stop. You know, I think the bottom part, just because it's like a different weight and it's like, I mean, even if you had it perfectly weighed out, I think that the one that the electricity is going through is going to be moving slower than the ones with the permanent magnets. Now, if you had them both electromagnets and you had it timed properly to, pulse on each other, that might work. And that might work really, really well, actually. To not use permanent magnets at all, but to use like a solid iron cores and electromagnets just on both sides, and have the north type of thing. You know, you can control how fast it goes. There's lots of things you could do if they were both electromagnets. That might be my next project. Have to get some strong, some good iron cores for that. $3,800. Boom. 3,800 divided by 3 is going to be 1,400. Wow, dude, that's so fast. That is so fast. For the battery operated, axial flux, gyroscopic DC pulse motor. Now, with closing, I'd like to say I want to spin the neosphere in a multi directional, like say this is the X plane, right? X going side to side, right? Then Y would be up and down. So we make another 120-degree circuit around the sphere, which would be right here, going up and down on this plane. Okay, the Y plane. And it's a plane. The line goes all the way to infinity on this plane. Okay? So we'll put 3 more on the Y, and then the Z. You gotta get the Z plane too. What's up, Caleb?
Hi.
Yeah, we're closing up. What's up, son?
She's trying.
I was not.
Oh, please don't.
Get over.
She's trying to make me do stuff.
Alright, you guys, I'll be out in a second. Please, go. I'll be out there in a minute. Alright, my kids are starting to have a little bit of a spat. I gotta wrap it up. Thank you so much. Thank you. I'll catch you again on the next one. Peace out. Love you guys. Bye now.